So trapezoidal rule. So while applying the trapezoidal rule, boundaries between the ends of ordinates are assumed to be straight. That means what? Consider this particular area where you need to apply the trapezoidal rule. Okay. So actually what happened, the boundaries between the ends of ordinates are assumed to be straight in case of trapezoidal rule. That means these boundaries, a second, that means these boundaries are assumed to be straight while you apply the trapezoidal rule. Okay. So consider this one, these ordinates are O1, O2, O3, O4 and O5. Okay. And consider these are the common distance small d, that means all the ordinates are at equal interval, that is d. So we can write over here that d is the common distance or interval, you can say, and O1, O2, O3, these are the ordinates. Okay. So if you need to determine area of this single portion, how you can determine? So that will be d by 2, because if you consider this one as a trapezium, so this is the distance between two parallel lines and the parallel lines is O1 and O2, right. So d by 2, that means the distance between parallel lines by 2 into the summation of the parallel lines, that means O1 plus O2. So O1 plus O2. Now if you determine the second area, that means if you determine the area of the second portion, so what will be the area then? That will be equals to d by 2 into O2 plus O3. Similarly, if you consider this particular portion, that will be d by 2 into O3 plus O4, and the last portion, let us determine it. So plus d by 2 into O4 plus O5. So if you sum up all this, what you will get is d by 2 into O1 plus 2 into plus 2 into O2 plus O3 plus O4 plus O5. So this is actually the formula of the trapezoidal rule. That means it will become d by 2, that means the common distance by 2 into first ordinate plus the last ordinate. This one is the last ordinate and this one is the first ordinate, plus 2 into sum of other ordinates. So this is the rule, that means the trapezoidal rule. Okay. So we will see a problem and we will solve a problem using this particular rule. So this is very simple one and important also. So let's solve that. So the following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meter. That means it is the same problem which we solved in average ordinate rule. So now we will solve using the trapezoidal rule. So let's draw the problem. So the first one is 0 and it should be 2.50. So 0, here it is 2.50, then 3.50, then 5, then it is 4.60 and then 3.20. Okay. So now what we need to do is we need to apply the trapezoidal rule. So before applying that, let's write the ordinates. This is O1, O2, O3, O4, O5, O6 and O7, and the distance that means the common distance is D, that is equals to 10 meter over here, right? So the total distance is 60 meter, because we have over here 6 divisions. So 6 into 10, that is 60 meter. Now if we apply the trapezoidal rule, the area will be common distance by 2. So common distance over here is 10. Let's write it like this: D by 2 into first ordinate plus the last ordinate. So first ordinate over here is O1 and the last is O7. So O7 plus 2 into others. Plus 2 into others. So what are the other ordinates? O2 to O6. So O2 plus O6. So if you put the value, you will get the area using the trapezoidal rule. So the value of D is 10 and it is 2. The first ordinate and last ordinate is 0 for both the cases, and 2 into others. So if you sum up all these value, so 2 into the other ordinates, that means 2.5, 3.5, 5.0, 4.60 and 3.20. So you just need to put the value after calculation, and finally the value that you get, that is 188 meter square. Okay. So in this way you can apply the trapezoidal rule to determine a area. And important thing is that here when you apply the trapezoidal rule, you keep in mind that the boundaries between the ends of ordinates, that means these boundaries are considered to be a straight line. Okay, these boundaries are always considered to be a straight line when you consider the trapezoidal rule. So Simpson's rule, very important. In this rule, the boundaries between the ends of ordinates are assumed to form an arc of a parabola. That means previously in case of that means in the previous case, if we have two ordinates and if we need to determine the area, we consider the boundary as a straight line, right? And this is for the trapezoidal rule as well as the mid ordinate as well as the average ordinate rule. Boundaries are considered to be a straight line, but here in Simpson's rule, here the boundary is considered to be arc of a parabola. Okay, and so similarly the formula is also different for this also. We will derive the equation, that means the Simpson's rule, how that is came. Okay, so let's start the derivation. look, if we consider uh, these 3 consecutive ordinates, let us consider 3 consecutive ordinates. This is O1, this is O2 and this is O3. Now definitely the boundary is not straight line, it is a arc of a parabola, right. Now if we divide this total area, we need to determine the area, right. So if we divide this area into 2 parts, like first part is this particular area. Look, first I am giving the nomenclature. Consider this is A, B, C, D, E, F, this is E. Now I am also making some imaginary lines over here to make it clear. Okay, and I am also giving the name over here F, E, D. Okay. So if we divide the total area into 2 parts, the first part will be AF DC, this is the trapezium, plus the segment, this particular segment, that is FEDEF, FEDEF. Now if we divide the total area into 2 parts, this is the first part and this is the second part. Now we will determine the area of these individual portions. Okay. So the first one, that means the area of this trapezium, that means AFDC, that is very much simple. So one more thing, the common distance is this one, this is common distance, that is D, and here it is also D. This is the common distance, that means distance between 2 consecutive ordinates, right. So to determine the area of this trapeze of this portion, to determine the area of this portion, that is AFDC, what will be the value? Very simple, the parallel distance between 2 parallel lines, that is O1 and O3, is 2D. So 2D by 2 into O1 plus O3, O1 plus O3. So this is the area for this particular portion, that is AFDC. Now what will be the value of this particular area, FEDEF? So the area of this segment, that is FEDEF, this particular portion, what will be the value? That will be the 2/3 the area of this parallelogram, that means FFDE. Okay. So what will be the value? 2/3 into this particular height, that is E, that means small e into capital E, that means small e and capital this particular distance, and the distance between A and C, that means 2D. So this is the area of this segment. Okay. So what will be the value of small e in capital E, that means this particular distance? The total distance that we already know, that is O2, right, from here to here, this is O2. So we just need to subtract the average height of this O1 and O2. Average height means the average value of this O1 and O3. So, what is the average value of O1 and O3? Simple O1 plus O3 by 2. So, that particular value we need to deduct from this O2. Okay. So, the final value will be 2/3 into O2 minus O1 plus O3 by 2 and into 2D. So, this is the area of this segment FEDEF. Okay. Now, if you make the summation of these two total portion, now if you make the summation of this AFDC and this segment FFDEF, okay. So, the finally you will get, solving these two summation of these two values, it will be D by 3 into O1 plus 4 O2 plus O3. Okay. Now, this particular thing, if we consider simple 3 ordinates O1, O2 and O3. Now, similarly, if the ordinates is something like this O3, O4 and O5. So, the result will be, that means considering these 3 ordinates, what will be the value? The value will be D by 3 into O3 plus 4 O4 plus O5. Now, if you make the summation of, if you consider this is delta 1 and if you consider this is delta 2. So, if you add this, what you will get is that, suppose delta equals to D by 3 plus O1 plus 4 O2 plus 2 O3 plus 4 O4 plus O5. So, the final expression that we got after derivation, that is the area equals to common distance by 3 into first ordinates plus last ordinate plus 4 into sum of even ordinates and plus 2 into sum of odd ordinates. So, in this way you can determine the Simpson's rule. So, if we consider O1, O2, O3, O4 and O5. So, if we, and the common distance is D. So, the ultimate final expression will be D by 3 into O1 plus O5, because this is the first one and this is the last one, and plus 2 into the odd number of ordinates, that means over here the only one odd ordinate is there, that is O3, and plus 4 into even ordinates. So, here O2 and O4. So, O2 plus O4 and yeah. So, this is the final expression to determine the area considering 5 numbers of ordinates. Okay. So, in this way we can solve any problem. So, consider this problem, that is same one. So, this is 2.5. So, the following offsets are taken from a chain line to an irregular boundary line to an interval of 10 meter. So, these are the data given. So, we need to solve the, that means determine the area using the Simpson's rule. So, let us draw the diagram first. So, first one is 0, then 2.5, 3.5, 5, 4.6, 3.2 and it is 0. As we already know, the boundaries are considered to be arc of a parabola, right? So, consider there are some arc is there. So, the boundaries are not considered over here a straight line, right? Here the boundaries are considered to be an arc of a parabola. So, this is O1, this is O2, O3, O4, O5, O6 and this is O7, and the common distance over here all are 10 meter, right? So, let us write the formula for the Simpson's rule. So, the area will be d by 3, first ordinate is O1 and the last ordinate is O7 plus 4 into sum of even ordinates. So, here the even ordinates is, so 2.50, 5.00 and 3.20. This is O2, this is O4 and this is O6. So, we just write over here that O2 plus O4 plus O6 plus 2 and 2 into the odd ordinates, that means 3.5 and 4.60. So, this is O3 and this is O5. So, O3 plus O5. So, if you put the values, that means the value of O1, O2, O4, O6 and O3, O5 and also the value of D, that means 10 meter, we will get the area. So, let us see what is the value of the area. That is 196.66 meters square. 196.66 meters square. Okay. So, this is the area if we consider the Simpson's rule. So, what is the basic differences between the trapezoidal rule and Simpson's 1/3 rule? So, what are the differences between the trapezoidal rule and Simpson's 1/3 rule? If we make the difference, look, first of all, as we already know that for this Simpson's 1/3 rule, we need the odd numbers of ordinates. Look, at the time of derivation of Simpson's rule, you already know we considered 3 numbers of ordinates, right? So, that means if we do not have the number of ordinates in odd numbers, we can't apply the Simpson's rule. That means here the number of intervals should be even number, that means here it is 1 and 2, there are 2 intervals. So, that is why here the number of interval is 2, which is even, and here the number of ordinates is odd, that means 3 numbers of ordinates is there. So, we can apply the Simpson's rule where these 2 conditions satisfy, that means the number of ordinates is odd and the number of interval is even. Okay. So, if these 2 conditions satisfy, then only we can apply the Simpson's rule. But yeah, there is no limitation of the trapezoidal rule, because at the time of derivation we have not defined that whether the number of ordinates is odd or even. Okay. So, for both odd and even numbers of ordinates as well as the number of intervals, we can apply the trapezoidal rule, but yeah, in case of simple in case of Simpson's rule, there are some limitations. Here the number of ordinates is odd and the number of interval is even. Now, as we already know, another difference at the time of derivation, I already mentioned that the boundaries in the Simpson's rule, the boundaries are not considered to be a straight line, but at the time of trapezoidal rule, the boundaries are considered to be a straight line. So, this is another difference. Also, as we considered in Simpson's rule, the boundaries as arc of a parabola. So, the result is very much accurate in Simpson's rule compared to the trapezoidal rule. Okay. So, these are the basic differences between the trapezoidal rule and Simpson's rule. So, very important. So, try to solve some problems on using these formulas. So, in the next class I will show some more problems and I will solve by all the methods, that means all the rules like the mid ordinate rule, the average ordinate rule, the trapezoidal rule as well as the Simpson's method rule, and then we will compare the result with each other. Okay. So, thank you.